All right, quick review. Last time we talked about inverse functions, right? And I think I told you that the rest of the chapter was going to deal with exponential and logarithmic stuff. Today we get to talk about exponential functions. Before we go there, let's do a quick review of exponents and their properties. The rules, if you will remember, if you have like bases, down here the bases are like, and you're multiplying. So a to the m times a to the n, what do you get? A to the m plus n. You add the exponents. A to the m times a to the n is a to the m plus n. If you are dividing like bases, number 2, a to the m divided by a to the n is going to be a to the m minus n. You're going to subtract the exponents. If you have a power to a power, number 3, a to the m to the n is a to the m times n. You multiply the exponents. Okay, for number 4 and number 5, do you see that number 4 you have a times b quantity to the m? And on number 5 you have a divided by b quantity to the m? You can distribute that exponent. You distribute that exponent over multiplication and over division. So a times b to the m becomes a to the m times b to the m. A divided by b quantity to the m is a to the m divided by b to the m. Now the caution over to the right. A plus b to the m. You cannot distribute over a sum. That is not equal to a to the m plus b to the m. The only time you can distribute that exponent is if you have multiplication or division. And why? Go look at the example. Let's do a plus b squared. What does that mean to do? A plus b times a plus b, right? And you have to go FOIL. First terms give you a squared. Outer terms give you ab. Inner terms give you ba, which is also ab. And the last terms give you b squared. So you get a squared plus 2ab plus b squared. If you were to have just distributed that squared and said a squared plus b squared, what would you have forgotten? The 2ab. So be careful. Do not distribute an exponent over a sum or a difference. And I will tell you that even the Cal 2 and Cal 3 students do that on occasion. And I just want to grab them and shake them and say this is something you should have learned long before college algebra. No, 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 no. Can't do that. All right, a to the minus n. What happens when you have a negative exponent? If you want to get rid of the negative, you reciprocate it. So that becomes 1 over a to the n. To get rid of the negative in the exponent and make it a positive exponent, you have to reciprocate. Okay, a to the m over n. If you have a fraction as an exponent, the denominator is the same as the index of a root. You can write this 2 ways. You can say a to the m to the 1 over n, or you could say a to the 1 over n to the m, right? Why can you say it that way? What happens when you have a power to a power? You multiply them. So what's m times 1 over n? M over n. All right. So you can write it one of 2 ways. You agree? If you were to write it this way, that's saying take the nth root of a to the m. If you were to write it the second way, that says take the nth root of a and then raise it to the nth power. Okay, let's go look at some examples using those properties. Number 1, you have x to the 7th over x squared. Let's make this a little bit more challenging. Let's say to the negative 3 power. Let's simplify inside the parentheses first. What is x to the 7th over x squared? What do you do to the exponents? Subtract them. So you get x to the 5th. Now you have a power to a power. What are you going to do with the exponents? Multiply. So you get x to the negative 15th. But somewhere someone said you don't want to ever leave a negative in the exponent. So you want to reciprocate and say 1 over x to the positive 15. There's your answer. Number 2, 16 to the 3/4 power. You can do that on your calculator, but how do you do it by hand? You remember what I said about the denominator? That's the root. So you want to take the 4th root of 16. What is the 4th root of 16? It's 2. And what do you want to do to it? You want to raise it to the 3rd power. So that's 2 to the 3rd power, which is 8. Now, this is the old operating system. That's how it looks on the calculator. On the new operating system, you would type in 16 raised to the power of, and it would keep it to the power of unless you tell it not to. You see 3/4? And then just hit enter. Okay, number 3, 27 to the negative 1/3 power. 27 raised to the power of negative 1/3. And I want to turn that back into a fraction. I get 1/3. How do you do it by hand? First, I want to get rid of that negative. How? Reciprocate it. 1 over 27 to the positive 1/3, which is 1 over the cubed root of 27. And what is the cubed root of 27? 3. So my answer is 1/3.